Hello, I'm JD Zamfirescu-Pereira, a PhD student at UC Berkeley,
And I'm Susan Lin, previously a research assistant at UC Berkeley.
and today we'll be presenting Rambler, supporting writing with speech via LLM-assisted gist manipulation. So, picture this. You're at the beach. You're soaking up the sun, waiting for your friends to arrive, letting your mind wander. Or maybe you're reading an ebook, and suddenly you remember your Kai review is due in 3 days, and you just had an epiphany about why one of your assigned papers is brilliant. You want to start writing this review right away, but all you have is a mobile device. No one wants to type out a review on tiny virtual keys, to say nothing of also then editing that review with finger-based text selection on a small screen. Naturally, you could use the built-in dictation tools, which are quite good these days. Speech for text input can be 3 to 4 times faster than typing, especially when there's no physical keyboard or when you're away from a traditional workspace. Dictation can be quite useful. But it doesn't solve the editing problem, and most people don't speak the way they write. Dictation plus edits on a tiny virtual keyboard is not the best interface for writing. In this work, we take some steps towards designing better interfaces for writing with speech.
We draw on cognitive science literature, which suggests that speaking differs from typing in a few key ways. First, speech is much less pre-planned than written text. Second, when reflecting on spoken words, people tend to remember the gist of what they said rather than verbatim. Centering an interface around gist has been explored in a few recent systems, and we like to call these systems gist-based interfaces. These are interfaces driven by the explicit support for operations on the gist of the text, not just on the sequences of characters contained in the text. We set out to design a system that uses dictation and gist-based interfaces that operate at a semantic level. Such a system would need to support 1. Nonlinear composition, to enable users to speak or ramble as they wish without the pressure of coming up with something as organized as written text. 2. This also means support for iterative drafting that lets users take advantage of fast speech reduction. 3. The interface should help reduce the effort of reviewing and editing spoken text while maintaining users' control over the meaning of their composition. 4. Capturing gist and supporting this kind of editing is made easier by the advent of LLMs, but we want to be mindful of preserving user control around where and how changes are applied. And finally, 5, we choose to design for mobile devices, which dominate many people's computing lives and stand to benefit the most from better speech-to-text input, given their known challenges of interacting with text. We introduce Rambler, an LLM-powered gist-based interface that supports speech input and the review and conceptual manipulation of the dictated text. The basic building block in Rambler is a ramble, which is a container that holds content alongside multiple buttons for users to interact with that content and the overall structure of the document. Here's a demo. To begin writing with speech, users can press the New Ramble button at the bottom right to create a new ramble and start recording. When the user finishes recording a ramble, the LLM automatically cleans a transcript. Users can add new rambles as they speak to help segment their writing. As the basis of our interface, we provide manual macro revisions, such as manually splitting a ramble by hitting return, manually merging rambles by dragging and dropping, and reordering rambles by dragging. Users can also respeak a ramble, add on to a ramble, and if necessary, keyboard edit. As spoken text is more verbose, we provide gist extraction through semantic zoom in keywords to help users review their composition. The slider at the bottom of the interface adjusts semantic zoom, or the degree of summarization. Users can swap from the shorter summarization level to get a gist of what they said, to 25%, or a 50% summarization level to get more details, or back to the full transcript. Furthermore, users can also view and change the automatically highlighted keywords to help themselves grasp what concepts in their composition are being recognized as important. By toggling keywords within a ramble, and then pressing the cycle icon to regenerate summaries, users can change the summaries for that ramble. As spoken text is also more disorganized, we provide LLM-assisted macro revisions to aid the user. If users have generated a long ramble that contains multiple ideas, they can utilize semantic splitting by pressing the scissors icon to break the ramble into multiple smaller, more focused rambles. Semantic splitting prompts the LLM to split a ramble into multiple rambles based on content and meaning. If users have multiple rambles that they think are of similar idea or concept, they can select the related rambles and then press semantic merge at the bottom. This will prompt the LLM to merge multiple rambles into one ramble based on content and meaning. If users want to define a customized intelligent revision for a ramble, they can ask the LLM through Magic Custom Prompt. Let's click on the magic wand for the first ramble and type in "Rewrite to be clearer." We're also able to select the checkbox that says "Include keywords as context." Now, the LLM rewrites the text in the first ramble.
We built Rambler in part to better understand how the affordances of direct manipulation could be integrated with dictation to improve writing with speech. We had 12 participants perform 2 long-form text composition tasks, one with our Rambler interface here on the left, and another with the baseline, which is a traditional speech-to-text editor with access to ChatGPT. Overall, people really appreciated using Rambler. 10 out of our 12 participants preferred it over the baseline, and more than half felt likely to iterate with Rambler. The text quality did not differ significantly between conditions, and we found that Rambler better supports the review and iteration of spoken text. We're, of course, glad people enjoyed using Rambler and found our design effective, but what else did we learn more broadly from our study? So first, we observed participants interacting with Rambler in many diverse ways, as shown in this timeline diagram. Here, dictation is shown in red, and keyboard editing is shown in green. So for example, these 3 participants chose to do a lot of dictating up front and then revising. Other participants intermixed dictation with edits, as you can see here. Here, macro revisions are also all shown with an icon. You can see the paper for more detail on this, but as you can see here, there actually is a lot of variety and some quite interesting workflows too. For example, one of these participants, P3, third from the bottom here, is choosing to only use manual split with semantic merging to retain more control over the result of that semantic merge. Even though there was a lot of variety, all participants composed text primarily through dictation as expected, and all appreciated the automatic clean transcript function for preserving their word choices while removing most filler words. The ramble structure also received the most positive feedback, with participants praising its usefulness for organizing ideas. P1 in particular explicitly said that Rambler is clearly better for organizing. Quote, "I was able to move the ideas around." P3 said that Rambler was a lot more inviting of merging and smashing things together, so I could iterate a lot more. And P6 said the Ramble structure made it a lot easier to sort of keep track of what I was doing.
Our study also uncovered some surprises, shedding light on writing with speech and what functionality is critical. For example, we expected participants to utilize semantic zoom early on in their writing process to help review their dictated text before revising. A bit more than half the participants tried out semantic zoom, but some participants only used it at the end of their task. Rationales for semantic zoom usage were inconsistent. Some used it out of curiosity, while others used it to review what they had said or see if they had left anything out. One participant uniquely adopted semantic zoom as a tool to make their text more concise, instead of as a tool for review. There were also a couple other things we found surprising. Respeaking to add new text was used by a little more than half the participants, but surprisingly, respeaking to replace entire rambles was only used by 2 participants. Participants seemed to lean more on Magic Custom Prompt or keyboard editing to rephrase their rambles, rather than redictating. We were also surprised that nearly every participant relied on keyboard editing at some point to make micro revisions. Magic Custom Prompt was used more frequently than we expected, as it served as a catch-all tool to fill the gap between our fixed GUI operations and a user's diverse editing needs. We saw many participants use it for further cleaning or rephrasing of the transcript, as well as style changes. For example, one participant requested reformatting in the style of an academic paper, while another sought a job cover letter style change. This points to a long tail of LLM-enabled drafting and transformation capabilities that users want to use. Implementing these all as direct manipulation isn't feasible, lending support for the notion that future LLM-based systems should consider including both direct manipulation and open-ended natural language interaction. Lastly, keywords were used by a few participants in a more substantive way than we expected. They were used to communicate the participants' notion of what was the most important gist of a passage, such as when requesting a resummarization or using the magic custom prompt. We'd like to conclude with some tangible design implications. First, we want to highlight that the chunk-based macro revision affordances seem very useful. Many participants felt that the Ramble structure made it easier to discretize, visualize, and review their text composition. Being able to manipulate text in chunks is also very helpful on mobile platforms where precise input is a challenge. As one participant said, writing with speech lowers the barrier of writing by making it, quote, easier to start and capture one's loose thoughts before they run away. Second, there is still a need for customized requests in AI-assisted word processing, and Rambler is well served by having a mixture of deterministic shortcuts and custom prompts, offering users customization on multiple levels. Third, interfaces should maintain the ability to specify the locations of changes. Some participants use Magic Custom Prompt to split or reformat one large ramble into multiple paragraphs or other structures, indicating the potential usefulness of custom prompting for scopes larger than a single ramble. But part of the benefit of having operations applied to individual rambles is that changes are localized. In contrast, word processing through a conversational UI, like in our baseline condition, makes it difficult to apply changes at specific text locations and observe changes. Fourth, macro revision and micro revision go hand in hand and are complementary in serving users' goals. In our user study, keyboard editing was still used by most participants in the Rambler condition, even if visibly less than in the baseline condition. Fifth, Rambler offers a preview of future writing systems that can combine input modalities even on devices with keyboard. These systems can draw on the affordances of speech, keyboard, and other input modes as appropriate, relying on LLM underpinnings to help mitigate impedance mismatches, for example, by cleaning up disfluencies, and create new affordances, such as semantic zoom.
Thanks for listening. This was Rambler, joint work with Jeremy, Matthew, and Sauhard at UC Berkeley, under the supervision of Professor Can Liu from City University of Hong Kong and Professor Bjoern Hartmann from UC Berkeley, and in collaboration with Michael, Piyawat, Shanqing, and Shumin from Google.